When an extension ladder rests against the wall, it reaches 4 meters up the wall. The ladder is extended a further 0.8 meters without moving the foot of the ladder, and it now rests against the wall 1 meter further up. Okay, so what I'm going to do to start with here is I'm going to draw two diagrams. So let's have before and after. Okay, so to start with, it reaches 4 meters up the wall, and we don't know how long the ladder is. Let's just call that X. And after we've moved it, it's now goes 5 meters up the wall, and the ladder is now going to be X add 0.8. It's a bit longer than it was before. Right, here's a right angle because that's between the wall and the floor, and this length on the bottom is going to be the same in both triangles. So let's just call that, Y and Y. Alright, so on this triangle I know that y squared can be found by doing x squared minus 4 squared, using a bit of Pythagoras. I know that from this triangle that y squared can be found by doing x add 0.8 squared take away 5 squared. Alright, let's just expand this out a little bit. So FOIL here, x add 0.8, x add 0.8, we're going to multiply that by itself, minus 5 squared. So we get x squared. So first outside will be add 0.8, inside will be add 0.8x. So we're going to have 1.6x, and then 0.8 times 0.8 is 0.64, and I need to take away 25. So what I'm going to do, actually let's get this right the way down. So this is x squared add 1.6x minus 24.36 if I combine these two parts. Alright, and here we've got x squared minus 16. Right, now if I put these two expressions together, I'm going to get, they both equal the same y squared. So that means x squared minus 16 is actually the same as x squared add 1.6x minus 24.36. Okay, I don't need this anymore, and I don't need this anymore. Let's make some room. Right, simplifying this then, I can take an x squared off both sides. Alright, I can do that. And then why don't we add 24.36 to both sides. So I need to have negative 16 add 24.36. Okay, so if I've added 24.36 to both sides, I get 8.36 on this side. I've added this, so it's gone, equals 1.6x. X on its own then is going to be 8.36 divided by 1.6. So x is 8.36 divided by 1.6, which is 5.225 meters. Alright, so that is our original length of the ladder, and when the ladder's been extended it's going to be longer. Part A says what's the length of the extended ladder, so we do need to add 0.8 onto that. So let's get another colour, shall we? Part A, the answer is 6.025 meters. Alright. And the increase in angle that the ladder makes with the ground now that the ladder is extended. Okay, so now that it's extended, I want this angle here. And I know this length is this. This is 6.025. So I know two lengths, this one and this one. I'm going to need a bit of SOHCAHTOA to work out an angle. So let's just have a think. SOHCAHTOA. I have the longest one, so this is the hypotenuse, and I have the one on the other side of the angle, so this is the opposite side. So the one with hypotenuse and opposite is sine. So call this angle theta. Therefore, this is part B. Sine of the angle equals the opposite one, which is 5 divided by the hypotenuse 1, 6.025. That means that the angle itself is the inverse sine of 5 over 6.025. So, using my calculator, second sine of 5 divided by 6.025 gives me the angle 56.1 degrees. So that is my answer to part B.